Introduction. Hello and welcome to this in-depth video on chemical reactions and stoichiometry. In this video, we will be exploring the fundamental concepts behind chemical reactions, the different types of chemical reactions, and how stoichiometry is used to quantify chemical reactions. Part 1. Chemical reactions at the most basic level. A chemical reaction is a process in which one or more substances, the reactants, are transformed into one or more new substances, the products. Chemical reactions are happening around us all the time, from the food we digest to the fuels we burn. One way to classify chemical reactions is by the types of chemical bonds that are broken and formed during the reaction. The four main types of chemical reactions are synthesis reactions. In a synthesis reaction, two or more reactants combine to form a single product. The general equation for a synthesis reaction is A plus B AB. An example of a synthesis reaction is the formation of water from hydrogen and oxygen, 2H2 plus O2 2H2O. Decomposition reactions. In a decomposition reaction, a single reactant is broken down into two or more products. The general equation for a decomposition reaction is AB A plus B. An example of a decomposition reaction is the breakdown of hydrogen peroxide into water and oxygen gas, 2H2O2 2H2O plus O2. Single replacement reactions. In a single replacement reaction, an element replaces another element in a compound. The general equation for a single replacement reaction is A plus BC AC plus B. An example of a single replacement reaction is the reaction of zinc with hydrochloric acid, Zn plus 2 HCl ZnCl2 plus H2. Double replacement reactions. In a double replacement reaction, two compounds exchange ions to form two new compounds. The general equation for a double replacement reaction is AB plus CD AD plus CB. An example of a double replacement reaction is the reaction of silver nitrate with sodium chloride, OgNO3 plus NaCl AgCl plus NaNO3. In addition to these four main types of reactions, there are also combustion reactions, which involve the reaction of a fuel with oxygen to produce carbon dioxide and water. An example of a combustion reaction is the burning of methane, CH4 plus 2O2 CO2 plus 2H2O. Part 2. Stoichiometry. Now that we have a better understanding of the different types of chemical reactions, let's turn our attention to stoichiometry, which is the quantitative study of the amounts of reactants and products in a chemical reaction. Stoichiometry is based on the law of conservation of mass, which states that the total mass of the reactants must be equal to the total mass of the products in a chemical reaction. This means that the number and types of atoms on both sides of the equation must be the same. To use stoichiometry, we need to know the molar masses of the reactants and products, which are the masses of 1 mole of the substance. For example, the molar mass of water, H2O, is 18.015 grams per mole. The first step in any stoichiometry problem is to write out the balanced chemical equation for the reaction. Once we have the balanced equation, we can use stoichiometry to calculate the quantities of reactants or products involved in the reaction. For example, let's say we want to know how much carbon dioxide will be produced when 50 grams of methane is burned. The balanced equation for this reaction is CH4 plus 2O2 CO2 plus 2H2O. From the balanced equation, we can see that 1 mole of methane, CH4, reacts with 2 moles of oxygen, O2, to produce 1 mole of carbon dioxide, CO2, and 2 moles of water, H2O. To solve this problem, we first need to convert the given mass of methane into moles. The molar mass of methane is 16.04 grams per mole, so 50 grams CH4x, 1 mole CH4, 16.04 grams CH4, equals 3.115 moles CH4. Now we can use the mole ratios from the balanced equation to determine how many moles of carbon dioxide will be produced. 3.115 moles CH4x, 1 mole CO2, 1 mole CH4, equals 3.115 moles CO2. Finally, we can convert the moles of carbon dioxide back into grams using the molar mass of carbon dioxide, 44.01 grams per mole. 3.115 moles CO2x, 44.01 grams CO2, 1 mole CO2, equals 137.1 grams CO2. Therefore,
When 50 grams of methane is burned, 137.1 grams of carbon dioxide will be produced. Conclusion. In conclusion, chemical reactions and stoichiometry are essential concepts in chemistry. By understanding the different types of chemical reactions and how to use stoichiometry to calculate the quantities of reactants and products involved in a reaction, we can better understand the chemical processes happening around us and how to design new chemical reactions for specific purposes. Thank you for watching this video, and we hope that it has helped you to gain a deeper understanding of chemical reactions and stoichiometry.